Now we want to look at inequalities and graphs of inequalities of things like lines and hyperbolas and parabolas and all the other type of graphs that we've been doing. Now, there's a technique we need to follow to do this. Now, let's have a look at what we need to do. First thing we want to do is we ignore an inequality sign. We're just going to graph whatever equation we've got. So in this case, we've got a graph of a line. So y would be equal to x plus 2. So we can consider that. Y is equal to x plus 2. Now, if we draw that up, we know it's going to be a straight line. It's got a gradient of 1. It passes through the y-intercept of 2. So we're able to draw that up. You can substitute values, your x and y coordinates, intercepts in, and get your graph there. So graph it up like you normally would. Now, what we want to do is we want to see whether y is greater than x plus 2 when we consider all the coordinates that could take on values here. Now, really what we want to do is this region is either on one side or the other of the line. So then that will happen with all the type of graphs. So whether it's on this side or this side, we've got to work out which one it's going to be on. So what we do, we're going to test a point. Now, the point you pick is up to you, but I generally tend to try and test 0, 0. The reason being is that 0, 0 is easy to throw into an equation. There's less work you have to do. So, but you can pick any point. So by testing 0, 0, so the origin there, I'm going to see whether that point lies in the region. So if I throw that in, I get 0 greater than or equal to 0 plus 2. Now, is 0 greater than or equal to 2? It's not. So that's the point 0, 0 is not in that region that we want to shade. That means the other side of the line must be the region where this inequality is true. Because 0, 0 doesn't satisfy it, but all these values will. And you can test a value. Let's test 0, 10. So when x is equal to 0, y is 10. Is 10 greater than 0 plus 2? It is. So that point's in the region. Every point you choose over this side of the line will be in that region that we require. So that's how we start to do this one. Do our graph, make sure we test a point, and we can test either side. But then if the point holds, we shade that side. If it doesn't, then you shade the other side. So, and then you'll see there's our shading there, and that's what we were just explaining. So that would be y is greater than or equal to 2. Now, because it's greater than or equal to, the line's solid. If it was just greater than, we'd put a dotted line in there because it wouldn't be equal to that line. And if it was less than, obviously 0, 0 would satisfy that region, and we would shade the other side. So that's greater than, y is greater than x plus 2. This would be the side y is less than x plus 2. It would be one side or the other. Let's have a look at another one. X plus y is equal to we consider equal to 1. We draw up that line. But because it's not equal to an inequality, we'd only make it a dotted line. So hopefully you can see that's a nice dotted line there. And then we test the point. Test 0, 0. Does 0 plus 0 on the left-hand side make it less than 1? It's true. That really that keeps our statement x plus y less than 1 true. So that means 0, 0 must be in the region. We shade this side. So you can shade it how you like. I'm able to do it with the computer program, so it does not. But all you just have to do is indicate this is the side of where the region holds. That one side's not. And we again just make sure that the line's dashed. It's not in the region. It's not a solid line there. So let's have a look at some other ones. Y is less than or equal to 4 minus x. Again, graph up y is equal to 4 minus x. It looks like that line there. And then sub in 0. So 0 is less than 4 minus 0. That's true. So 0, 0 is in the region we shade. Y greater than x. Now this is one where it would go through the axis, the origin there. So that's the line y is equal to x. So I can't test 0, 0 because it's on the line this time. So what I would test is any other point. So what I try and do if I can't test 0, 0, I go for 0, 1. So I test is when x at the point 0, 1, is the y value 1 greater than or equal to 0? Sorry, 0, 1. I've actually tested that point. So then that's okay. I'll test this one. That's not a problem. 0, 1. Is 1 greater than or equal to 0? It's true. So that's the side that's going to be shaded. So that must be, because 0, 1's in the region. Now if I test 1, 0, just to make sure, as I was looking to do before, 1, 0, if I sub that into the equation, I'd get the y value being 0 and x being 1. 0 is not greater than or equal to 1, so that doesn't work. So obviously that's not in the region, and that's able to show us both sides are not work properly when I'm considering that region there. Let's have a look at this one. This is where we've got a circle. X squared plus y squared is equal to 4 would look like a circle. Center 0, 0, going around the radius actually it should be 2. We've put 4 there, but that's an error. That should be 2. So ignore those values. So that should be minus 2 there. And that should be minus 2 down there. So x squared plus y squared is greater than or equal to 4. Now, again, test the values. If I test 0, 0, which is inside the circle, now we're either going to shade inside the circle or outside the circle. 0 squared plus 0 squared. Is that greater than or equal to 4? 0 is not greater than or equal to 4, is it? So that doesn't work. 0, 0 is not in the region, so we shade the outside of the region. So that's why that part is shaded. So the parabola y is greater than or equal to x squared. Well, we know that's what x squared looks like. And then test the point. We can't test the origin again. So test 1, 0. So 1, 0 there. And so if we're testing that point, we sub it in. We get 0 greater than or equal to 1 squared. So 0 greater than or equal to 1. That doesn't work. That's not part of the region. So we shade the inside of the parabola. Again, it's either shaded inside or it's shaded outside the parabola. Y is less than or equal to 2 to the power of x. Again, we graph 2 to the power of x. Test 0, 0. We get 0 less than or equal to 2 to the power of 0. 0 will be less than or equal to 1. That means this part's shaded here. Now just be wary. Even though we have an asymptote, and we graphed y equals 2 to the power of x, and that's an asymptote, doesn't touch the x's. Any of these points here, though, satisfy that equation. So if you test something like 0 minus 1, and we put that in, so minus 1 less than or equal to 2 to the power of 0, then minus 1 is less than or equal to 1. That's true. So that's part of the region. So that's why the whole thing is shaded, and not just up to the asymptote. So don't be wary just because we have an asymptote there. It doesn't mean that the inequality doesn't hold in that regard there. X times y is greater than or equal to 2. Again, we graph our hyperbola there, and we test the point. Put 0, 0 in. So 0 times 0 is 0, and 0 is not greater than or equal to 2. So our origin's not in there. It's got to be shaded on the other sides of the hyperbola. Again, it's either shaded between the hyperbolas or on the outsides of the hyperbolas. Y is less than 4 minus x squared. Again, graph our parabola, test 0, 0, and you'll see that it holds. So that won't be part of the region there. An absolute value graph. So our absolute value of x looks like that. So where we substitute 0, 1 in there, because again we can't take 0, 0. So we put 0 in there, 1. 1 is greater than or equal to the absolute value of 0, so that's okay. So we shade the inside the graph there. This is one that I've seen before where lots of people get it wrong. Because again, we've got to consider, even though we can graph up square root of 4 minus x squared, and so that's our graph of that one. Even though we have that, it's not just the inside there. All these values all the way down here satisfy that inequality. So the inequality does a little bit more than just graph the line. Okay, it's considering a lot of different points. And again, test any point here, 0 minus 1, you put put 0 in there, and minus 1. Minus 1 will be less than or equal to the square root of 4, which would be 2. So minus 1 is less than or equal to 2. So even though the values technically aren't defined for some of the, like if we substituted the y values in, it would be, and that was if it was a circle, But it would be, if we considering in the inequality, the only case is it's going to be between -2 and 2. We can't throw any x values in that are less than -2 or greater than 2, because that would give us an error, because we'd take a square root of a negative number. But all those values that when we sub it in there will be greater than these y values. So that's what we're looking at when we do that one. So that's a special case that we have to consider. Now, we can also do ones where we need to combine different regions to get ones where they overlap. So consider this. That's x is greater than 0, greater than or equal to 0. That's y greater than or equal to 0. And x plus y less than or equal to 1. So when we have that, we're going to see where they hold simultaneously. So that's what we're looking at there. Where do these inequalities hold simultaneously? And it would be that triangle. You can see when you overlap them, that it's going to be that triangle in there. Now that little part there is where they're going to overlap. So that's why I've done it on a different graph to get that. But you can do all three shadings on the one graph. It's just where they all all overlap. A lot of times I see people use all different colors to do this, and where their colors overlap, then that would be seeing that we'd have the regions holding simultaneously. So here's another one. Where's x plus y greater than or equal to 0? So it'd be the blue shading there, and x plus y less than or equal to 2 would be the orange shading. And the orange shading really is on from the red line there, and where it's grey is where they hold in between there. So that would be where the two of them hold simultaneously, that grey area there. X squared plus y squared is greater than or equal to 4 would be the outside of that circle, radius 2. X squared plus y squared less than or equal to 9 would be circle radius 3 and inside. So it's going to be between those two circles. So that's where the shading comes in there. X squared plus y squared is between radius of 2, radius of 3, circles radius 2 and 3. Again, you see this one, we saw that one before. There's our semicircle and the area underneath it, and our parabola, the area between it. Where does it overlap? Well, in this area here where it's all grey. So that would be the region where those two hold simultaneously. And the last one here, we're looking at x times y is less than or equal to 2. So that would be the region between that shading there, that shaded area there. And so all this area in between there. And y is less than 2 is the, again, dotted line, and everything in between, everything underneath the exponential. So the black lines here indicate the area that needs to be shaded there. So it'd be all this part in here, all this part in here, and everything in between there. So again, shade them both up. Like get the shading there, get the shading there, and then you can see where they will overlap and make that a little bit darker, or rub out the other stuff. That's why it helps to do it in pencil. But that's what you're looking at when you do these types of graphs. So draw all the areas, graph all the regions up, the areas covered separately, and then get the places where they